Hey guys, this is part two of Unit 7.1, The Scientific Revolution. If you haven't watched part one yet, stop, back up, go watch part one and then join me for part two when you're ready. So we were just finishing up Kepler. Remember Kepler says orbits are ovals, okay? That mathematically makes more sense about how the solar system stays afloat and everything works, okay? And that heliocentric, the sun is in the middle, makes sense. I agree with Nicholas Copernicus, says Kepler. All right, so keep those guys in mind. Draw a line underneath everything you just wrote all the way across your page. Give yourself a left-hand side question, all right? And move it on. Okay, so what is that showing me? Which theory? Which theory? Heliocentric, right? That's heliocentric. The sun is in the middle. And as you guys probably know, we are the third planet from the sun. All right. And all the different orbits are different oval shapes, which actually on that particular picture, they kind of look like circles. But no, they're ovals. Okay. Take my word for it. All right. So we've got Ptolemy who says, and Aristotle, and Ptolemy, they're saying, no, geocentric theory, the earth is in the center. That's taught for thousands of years. The Catholic Church promotes that idea. Along comes Copernicus in the scientific revolution and he says, nay, that is not correct. Okay, and he says the sun is in the center, heliocentric theory, and he is correct. Kepler backs Copernicus up and says, I agree. I do think heliocentric is correct, except orbits are ovals. They're not circles. Okay? Catholic Church doesn't like this, but it starts feeding out into the scientific community as a more and more accepted theory. Here's the thing you guys got to understand, and this is an FYI slide. You don't have to write this down, but listen up. For thousands of years, or like hundreds of years, really, two sources of wisdom had been perceived as accurate in Europe. Okay, remember we're discussing Europe right now. Okay, God in the Bible and Aristotle, who was a Greek philosopher during classical times with Greek and Roman times, right? Pretty much all human knowledge, if you went to school, you went to university, you learned something from your mom or dad, you learned something at the local church, okay? All of the knowledge that's getting passed around says this source of information is true because the Bible said so, or this source of information is true because Aristotle said so. Okay, so to go in like Copernicus or Kepler and say, no, what you've been taught for hundreds of years is totally wrong. Nobody likes being wrong. This did not go over with the average citizen quickly or well in the beginning because change is slow. It takes time. In scientific communities, it got accepted faster, but still took time. And eventually it feeds out into more and more of the general populace. But change is slow, guys. Okay? And the Catholic Church was powerful. And they had taught geocentric theory for a long time. Okay? They were not quick to say, oh, just kidding. We have been wrong for hundreds of years. Nicholas Copernicus and Kepler are correct. Okay, that wasn't something that they were willing to do. All right, so they fight every step of the way saying, no, they're wrong, we're right. Okay, and it's this power struggle that ensues between the scientific community and the church. And this is just one example of that. There's hundreds of times where science said, no, the answer is this. But the Catholic Church had said, no, the answer is that. Okay, and some people were like, wait a minute. Why is there a power struggle? Why can't like both things be blended together? Sometimes science gets it wrong. Sometimes the Catholic Church got it wrong. Why don't you guys work together to figure out the best, most newest information and technology and stuff using those things, figure out the right answer. So some people's attitude was like, let's be harmonious. And other people were just like, you're wrong, I'm right, you're not right, you know. Okay. All right. So keep that in mind. All right. Along comes Galileo. All right. So Galileo, Q6, write it down, highlight it yellow. Galilei, okay. He's a guy who studies Copernicus's theory, among other things. Galileo is an amazing scientist and philosopher and thinker of the Renaissance and scientific revolution time period. All right. And he studies Copernicus's theory, and it was a theory at that point. Copernicus couldn't definitely prove for sure without a shadow of a doubt that heliocentric theory was correct. But he theorized through mathematical equations and observation and things that this makes more sense than geocentric theory. Well, Galileo likes the idea of Copernicus's heliocentric findings and says, let's prove it. And Galileo invents a telescope. Okay, so who's the inventor of telescopes? Galileo. All right, so Galileo, using telescopes, is able to see things, obviously, that the naked eye by itself looking out into the night sky would normally not be able to see. And so using the telescopes, he ends up being able to prove that heliocentric theory is in fact correct, okay? And the Catholic Church had to kind of eat some crow, which means they had to admit that they were wrong, something they still didn't want to do very quickly and took a long time, and they really fought because they don't like being wrong, all right? So he used, though, Galileo, observation and experimentation. This is going to become something that to you guys, like, yeah, in science class, since like first grade, you've learned observation and experimentation is part of science. Like, duh, that's just common sense. Well, it's common sense to you because you've been taught that since you were, born or have ever talked about science. You got to remember that at some point, it wasn't such common sense. It wasn't something that was regularly done. And Galileo was one of the first people to promote, hint, hint, wink, wink, important information, the idea that we need to observe things as scientists. Like, we should be able to prove them through observation and experimentation. Experimentation is important because in the scientific field, if I produce something through an experiment, if I get certain results, if those results are accurate, anybody else should be able to do that experiment and also get the same or very, very similar results to me, right? That just makes sense. To us, it just seems like obvious, right? To the people of the Renaissance time period, this was like, light bulb! Amazing! That makes so much sense. We need to observe and we need to experiment. Ta-da! All right, so keep that in mind. Highlight, highlight, highlight all that super duper important stuff with your super duper very important highlighter color. Draw a line underneath everything you just wrote all the way across your page. And here we go. Push pause if you need more time. Galileo's famous for a lot more than just inventing the telescope and backing up Nicholas Copernicus and Kepler with heliocentric theory, guys. He does a lot of experiments about objects and velocity and wind resistance, mass, all these kind of things, okay? A lot of people used to think that if you walked up to the top of a tower and you dropped a bowling ball and a tennis ball off at the same time, that the bowling ball's heavier, so it's going to fall first. The Catholic Church had taught that for a long time. Scientists and teachers had taught that for a long time. And it hadn't occurred to anyone to actually walk up a tower and drop a heavy object and a light object at the same time to see what happens. Galileo's the first guy that goes, whoa, experimentation and observation are important. So let's actually try it. What a novel idea. And so he goes up a tower and he picks something light and something heavy and he drops them and they're similar shape. Okay, that's important. And he finds, guess what? They fall at the same rate. Okay, if an object is a similar size, mass, shape, they're going to fall at the same time, even if one's heavy and one's light. Now, air resistance can change that, of course. If you drop a bowling ball and you drop a leaf off of the side of a tower, because the bowling ball doesn't have a lot to interfere with it, it's going to drop faster, right? Then the leaf has a lot of little edges on it that will catch air resistance and it's going to make it fall more like this. So obviously those two things would not fall at the same rate. But he does all kinds of experiments with that sort of thing and more. Okay, there are some videos on Galileo. Make sure you take a look at those in the flipped classroom area of the website. Moving on to another famous scientist who challenged things from classical thinking and from the medieval period, Isaac Newton. Okay, so highlight Q7, Isaac Newton, with a yellow highlighter. He's from England. He was also a scientist. And he does a lot of things too. He does a lot of experiments with light and how light fractures and hits, why do you get rainbow prisms and how color works and how light and color are reflected by your eye. So he does a lot of work with that. But what Newton is most famous for is gravity. And it's a very common misconception when you guys don't think it through. Oh yeah, he invented gravity. Wait a minute. Did he invent gravity? No, we've always had gravity, right? Okay, but he's the one that figures out that it's actually a thing because you can't see gravity. You can see it in action by the fact that stuff falls when you drop it, right? But you can't actually see gravity in the air or anything. So he's the one that figures out, hey, it exists, and how does it work? How does it impact objects in the environment? Okay. So he comes up with a set of laws and principles of how gravity behaves and responds and acts in real space and real time. And he calls them universal gravitation theory. Sometimes you'll also hear it called universal gravitational theory. Same thing. Okay, so universal gravitation theory. And just like Galileo, hint, hint, wink, wink, observation and experimentation. Can you figure out how gravity works and that the cup is going to fall without observing that, right? Without doing experiments, okay? No, not so much. So using this newfound idea of, hey, experiment, hey, observe things, all right? He ends up coming up with a set of laws about how gravity behaves. And this is a game changer in the field of science and how engineering and mechanics and things of buildings and stuff will happen moving forward. All right, so that's Isaac Newton. He's most famous for universal gravitational theory. How does gravity behave? Okay, draw a line underneath everything you just wrote all the way across your page. Give yourself a left-hand side question. All right. There's a really famous story about Isaac Newton sitting under a tree and an apple bopping him on the head while he's sitting there, and that making him think, oh, why did the apple fall on my head? Okay. Sort of true, sort of not. He's actually looking out from a window onto his property where there is an apple tree, and the apple tree happens to lose an apple while he's looking out the window, right? And the apple falls to the ground. And that gets him thinking about, well, why did it fall? Why did it behave that way? Why did it fall as fast as it fell? Why did it hit the ground? Okay. So it's a cuter story to say it actually bumped him on the head, but that's actually not true. All right. Okay, there is a video clip on Newton you can watch in the flipped classroom area. Remember that and take advantage of that. Q8, the microscope. All right, Zacharias Janssen invents the microscope almost in the 1600s in 1590 during the scientific revolution. Okay, obviously you guys all know that we can't see everything with the naked eye, just like we can't see up into space everything without the aid of a telescope. Well, we can't see all the little germs and cells of things, right, without some sort of aid that enlarges stuff for us. And Zacharias Janssen invents the microscope in the late 1500s. Once that is invented, it is not very long at all before we figure out, hey, germs, they're a thing. Because remember, they didn't know how people got sick. They didn't understand how, disease spread from one person to another. They didn't realize things existed in their environment, guys, they couldn't see with the naked eye. Why would you know that, right? Why would it even occur to you? You would just assume if it existed, you could see it. But then a microscope comes along and you look underneath it when you take your little slides and look at stuff and you go, holy crap, whoa, there's all this stuff I didn't even know existed, right? And so bacteria is discovered by a guy named Anton van Leeuwenhoek. When we're in person in class, everyone always likes saying that because it's like you're going to spit a loogie out. Okay, Anton van Leeuwenhoek. All right, he's the guy that discovers bacteria using Zacharias Janssen's microscope. And then, of course, lots of other things are discovered. We figure out how, plants behave and how they grow, and that leads to photosynthesis being discovered. And we discover, how animal cells and plant cells differ and how different types of bacteria and virus cells behave and, all those kind of things, what blood cells look like and what they do. And all this stuff's going to happen because of the microscope. telescope getting invented. All right, we're almost there, but not quite. So we're going to have to do a part 3, guys. When you're ready, then join me for part 3, and I will see you then.